Hello, in this video, we will be looking at the calculation of the total revenue, the average revenue, and the marginal revenue when we have the question in an equation form. We will be looking at the revenue concept in an equation form. If you'd like to see the revenue concept in a tabular form or in a schedule form, please check the video up here or you may refer to the description below. Moving on to the question we have at hand, this question says, given that the demand of a firm is Q equals 40 minus P. So the first question says, what is the total revenue function? A, we are looking for the total revenue function. We know that the total revenue is equal to the price times the quantity. But in this case, the only information we have is the quantity function here, which is the demand. So we know that Q equals 40 minus P. So all we are just going to do is that we substitute this Q into this equation here. So we will have total revenue equals P times, instead of writing Q, we write 40 minus P, and then we can simplify. This approach is correct and there is no problem with this. The only issue is that the total revenue is expected to be a function of quantity. But if we simplify this calculation that we have here, if we simplify it, we'll realize that the total revenue we're going to get from this is going to be a function of price. The correct form of a total revenue function is the total revenue function is meant to be a function of quantity and not a function of price. Total revenue is expected to be a function of quantity and not a function of price. So to make total revenue a function of quantity, this means when we go back to what we have here, so we have total revenue equals price times quantity. The reason why we have total revenue as a function of price in this equation here is because we substituted the quantity in, but to make the total revenue a function of quantity, we have to first make sure that we are substituting price and not quantity. So we have to make sure that we are substituting price and not the quantity. But based on the question that we have here, we can see that the demand is given to us in Q equals 40 minus P. If we are going to substitute P and not Q, we have to make sure that we convert the demand function by making the price the subject of the equation, which means we will have what is called the inverse demand function. So the demand function given to us is Q equals 40 minus P. What we are going to do is make P the subject of this equation. So we will have Q, P comes to the left, so it becomes plus P equals 40. To make P stand alone, we have P equals 40, Q comes to the right, so we have minus Q. And this is the demand, or more accurately, this is the inverse demand function. Now we can see that this demand function that we have here is a function of Q. That is, price is a function of Q. So since price here is a function of Q, we can easily get a total revenue that is a function of Q. Here, the quantity was a function of price, as we can see here. That is why we ended up with a total revenue that is a function of price. So if you want to get your total revenue as a function of price, you use the quantity as a function of price. But if you want to get a total revenue that is a function of quantity, you have to use the price that is a function of quantity. So now let's calculate the total revenue. Total revenue, as we know, is price times quantity. So as we said, we are substituting the price. So total revenue equals price is 40 minus Q. So we substitute this price here into the revenue calculation. So instead of writing price, we write 40 minus Q, then times Q. So simplifying, the total revenue equals, to avoid confusion, let's rewrite this as 40 minus Q, then Q, since bracket means multiplication. So opening this parenthesis, total revenue equals, so we do 40 times Q, that's 40Q, minus Q times Q, that's minus Q square. And this is the total revenue function. And this is the answer to question A. Question B says, what is the average revenue function? B, the average revenue. We know that average revenue equals the total revenue divided by the level of quantity. Applying this formula, that means the average revenue equals the total revenue is 40Q minus Q square divided by Q. Simplifying this, we have the average revenue equals 40Q divided by Q minus Q square divided by Q. Average revenue equals 40Q divided by Q, that's 40, minus Q square divided by Q, that's Q. And this is the average revenue function. You can leave your answer in this format here, but it's better to leave the answer in this format here, as this is the simplified average revenue function. And this answers question B. The next question, which is C, it says, what is the marginal revenue function? C, the marginal revenue. The marginal revenue equals the change in the total revenue divided by the change in the quantity. Since this question is in an equation form, since our total revenue is in an equation form, so that means the marginal revenue equals change in total revenue divided by change in quantity. Simply means we take the derivative of the total revenue with respect to the quantity. So this means marginal revenue equals, we are taking the derivative of this total revenue function with respect to Q. So the derivative of 40Q with respect to Q is 40. Next part, the derivative of minus Q square with respect to Q is minus 2Q. Minus 2Q. And this is the marginal revenue function. If we are not familiar with differential calculus, let's break down how we do this calculation. So first, we have the total revenue function, which is equal to 40Q minus Q square. So the derivative of this total revenue function with respect to Q, which is the marginal revenue. So the marginal revenue is the derivative of the total revenue function with respect to Q equals, how did we get 40? So what we did was that we go to 40Q, the power of 40Q here is 1. So we bring this 1 down, multiply it with the existing coefficient, which is 40, and then we write Q back, subtract 1 from the power, and that's done with the first part. We go to the second part, which is minus Q square. The power in minus Q square is 2, so we have minus, we bring this 2 down. After bringing the power down, we multiply it with the coefficient of Q square. There is no number beside Q square, so we skip that, and then we write Q back, and then the power 2, but now we subtract 1 from the power. So what we just did was apply the simple rule of differential calculus. So simplifying, that means the marginal revenue equals 1 times 40, that's 40, then Q, 1 minus 1, that's 0, minus 2Q, then 2 minus 1, that's 1. So marginal revenue equals 40, Q raised to power 0, Q raised to power 0 is 1. In mathematics, any number raised to power 0 is 1. Then we have minus 2, Q raised to power 1 is Q. So simplifying, we have the marginal revenue equals 40 times 1, that's 40, minus 2Q, which is what we have here. And this is the way we apply differential calculus to find the marginal revenue function. If you are not familiar with how to perform the differential calculus, please you may refer to the video up here or check the description below. We have a video on that. And this answers question C. Next question, which is D, it says, what type of market is this firm operating in? So based on the information that we have so far, this is the total revenue function. This is the average revenue function. This is the marginal revenue function. To determine the kind of market the firm is operating in, there are lots of ways we can do that. The easiest way is simply just to look at the marginal revenue. Here we can see that the marginal revenue is 40 minus 2Q. In mathematics, an equation that looks like this is called a linear equation. So the marginal revenue is a linear equation. What is a linear equation? A linear equation is an equation whereby the variable is having a maximum power of 1. So the variable we have in this question are the marginal revenue variable and the quantity variable. The power of the quantity here is 1. And just like the same way, the power of the marginal revenue here is 1. So the linear equation, or if you can recall from basic mathematics, the linear equation in general is y equals c plus mx, or some notation use y equals a plus bx. So we can see that either this notation or this notation, it looks exactly like this. So in this situation, y is the marginal revenue, c is 40, and mx is 2q. So this is a linear equation. There is also another type of equation, which is what we call the constant equation. A constant equation can be generalized as y equals c. That is whereby we have a particular variable that is equal to a number. So for example, I can say marginal revenue equals 30. So y here is MR, the marginal revenue, and C is 30, which is a constant number. So which means there is no Q. Why are we making mention of this? When the marginal revenue is a linear equation, then most likely the firm is operating in a monopoly market, or the firm is operating in a monopolistic market. But if the marginal revenue is a constant equation, that is, the marginal revenue is constant, then most likely the firm is operating in a perfectly competitive market. So when we have a linear equation, when the marginal revenue is a linear equation, the firm is most likely operating in a monopoly or a monopolistic market. But if the equation is a constant equation of a marginal revenue function, then definitely the firm is operating in a perfectly competitive market. To confirm this, when we draw a linear equation, if we are to draw a linear equation, the graph usually looks like this, either upward sloping or downward sloping. So depending on how you draw. But for the marginal revenue function that we have in this question here, if we draw the marginal revenue function, we will definitely have this as our marginal revenue. if we are to draw this function. So this will be the marginal revenue function. So which is a downward sloping, and a downward sloping marginal revenue function only occurs in a monopoly market or a monopolistic market. However, if the equation is a constant equation, the graph of the marginal revenue is going to look like this. This will be the marginal revenue graph. That is, marginal revenue equals 30. So we have 30 here. That is irrespective of the level of quantity. When your quantity is 1, marginal revenue is going to be 30. When your quantity is 2, marginal revenue will be 30. When your quantity is 3, marginal revenue is going to be 30. That is the meaning of MR equals 30. That is, irrespective of the level of your quantity, your marginal revenue is still going to be 30. And this can only happen in a perfectly competitive market. But if we come to this marginal revenue function that we have here that we calculated, marginal revenue equals 40 minus 2Q. This means as Q increases from 1, 2, 3, as the level of quantity increases, the marginal revenue is decreasing. So the marginal revenue is decreasing, downward sloping. You can take your time to check this out. Put Q as 1, calculate the marginal revenue. Put Q as 2, calculate the marginal revenue. Put Q as 3, calculate the marginal revenue. You will realize that the marginal revenue values are decreasing. Another way we can check the kind of market that the firm is operating in is that we know that the average revenue is always equal to the marginal revenue in a perfectly competitive market. So let's go to the average revenue function. The average revenue function is 40 minus Q. The marginal revenue function is 40 minus 2Q. So these two equations are not equal. They are not the same. So that means the firm is not operating in a perfectly competitive market. But we know that in a monopoly or a monopolistic market, the average revenue is usually greater than the marginal revenue at each level of Q. So at each level of output, we know that the average revenue is always greater than the marginal revenue. So if we look at it, for each respective value of Q that we have here, if we put in Q equals 1 here, the answer we get from this Q equals 1 will be greater than the answer that we get when we put Q equals 1 in the marginal revenue function. Same thing can be said for when Q equals 2. The average revenue will be greater than the marginal revenue at each level of quantity. So that just proves that most likely the firm is operating in either a monopoly market or monopolistic market. Another important thing we should make mention of is that the slope of the average revenue here equals minus 1, but the slope of the marginal revenue here is equal to minus 2. So when the marginal revenue has twice the slope of the average revenue, then the firm is operating in a monopoly market or a monopolistic market. But if the slope of the average revenue is equal to the slope of the marginal revenue, then the firm is operating in a perfectly competitive market. So that's another way you can prove that the firm is operating in a monopoly or a monopolistic market. So the answer to this question C is that most likely the firm is operating in a monopoly market or in a monopolistic market. And this answers question D. The next question, question E, says, find the output that maximizes the firm's revenue. In mathematics, whenever we have a function and we are trying to find the maximum of that function, so whenever we have the word maximum of a function, it simply means take the first derivative and equate it to 0. So whenever we have the word maximize, and in fact, whenever we have the word minimize, it simply means take the first derivative and equate that answer to 0. Based on this definition, we are trying to maximize the total revenue. So we take the first derivative of the total revenue with respect to Q and we equate it to 0. Derivative of the total revenue with respect to Q is nothing but the marginal revenue, as we have seen a few minutes ago. So what we are actually equating to 0 is nothing but the marginal revenue. We have the marginal revenue calculated already, which is this. Marginal revenue equals 40 minus 2Q. So we bring it down. Marginal revenue, which is the derivative of the total revenue with respect to quantity, and that's 40 minus 2Q, because this 40 minus 2Q is the first derivative of the total revenue equation. So we simply take this 40 minus 2Q and we equate it to 0. So equals 0. Solving, we have 40 minus 2Q equals 0. Now we can solve for Q. We can solve for Q. And Q is nothing but the output. So if we solve for Q, this will be the output that will maximize the total revenue. So let's solve for Q. So solving for Q, we have minus 2Q equals, this 40 comes to the right side, so we have minus 40. So divide both sides by the coefficient of Q, divided by minus 2 and divided by minus 2. So simplifying, we have Q is left on the left side, minus 40 divided by minus 2, that is 20. That means the output that maximizes the total revenue is 20 units. So when the firm is able to have a demand or is able to sell a quantity of 20 units, then the firm will be maximizing their total revenue. And this answers question E. The next question, which is the last, question F. How much revenue will the firm earn if the market price is $15? F. If market price is $15, how much is the total revenue? If you recall that the revenue function that we calculated is a function of quantity. This revenue function is a function of quantity. We don't have price here. So which means we can't just take the $15 and substitute it into this equation. If we have quantity, we can easily substitute it into this total revenue function. So for example, let's say we are looking for the total revenue when quantity is 15. We simply just say anywhere we see Q, we just put in 15. But this question is not saying quantity equals 15. The question says the price is equal to 15. So there are a number of ways we can approach. We can calculate the amount of total revenue using this because we already know the total revenue is a function of price in this particular revenue equation here. Using this approach, we can simply just substitute 15 here. So we can just put 15 inside this equation and then we easily get our total revenue. But since most of our calculation was not done based on this equation that we have here, that is using total revenue as a function of price, so let's not find our answer using this approach, but this can be used without any issue. So the approach we are going to use is that we have quantity here. Quantity equals 40 minus P. So we know that quantity equals 40 minus P. So price equals $15. So if price equals $15, we can easily find the quantity by saying Q equal 40 minus, instead of writing P, we simply substitute 15. So simplifying, we have quantity equals 40 minus 15, that's 25. Now we know our price and we know our quantity. We can easily calculate the total revenue by saying price times quantity. So the total revenue equals 15 times 25. So total revenue equals 15 times 25, that's 375. So the total revenue is $375. Or we can take this quantity, which is 25 units, and directly substitute it into this total revenue function. So we just go to the total revenue and we say 40 into, instead of Q, we say 25 minus 25 square. And we solve this. When you solve this, you get exactly total revenue equals $375. To summarize, the first approach for this question F is we simply take the $15, price equals $15. We substitute it into this total revenue equation that is a function of price, or we go through this second approach, and midway through this second approach, instead of continuing like this, we can just take the quantity and put it inside this revenue function. Any method or any approach you use should be acceptable. And this answers the last question, F. Hope you found this video beneficial. If you did, please leave it a like and kindly subscribe to the channel. Thank you very much for watching. See you in another video.